It's easy to get overwhelmed by the sheer complexity of the world. You look at something like biology, at the way a protein folds, and it feels like a problem that's not just difficult, but maybe fundamentally unknowable on some level.
Like nature is intentionally difficult, adversarial even. You run up against these problems that seem to have a practically infinite number of possibilities, and our traditional methods just hit a wall. It defines the boundary of what we think is possible.
Exactly. But there's this hypothesis from Demis Hassabis at DeepMind that kind of flips that on its head. He suggests that any pattern found in nature can, in theory, be efficiently discovered by a learning algorithm. It's a huge claim. It reframes the entire universe of problems we face.
That feels like it bumps right up against one of the biggest unsolved questions in computer science, the P versus NP problem.
Right. The article brings that up. Can you break that down a bit? It's one of those concepts that feels simple on the surface, but gets complicated fast.
I'll try. So P stands for problems that are easy for a computer to solve. Think sorting a list of names. The time it takes scales reasonably, polynomially, with the size of the list.
Okay, that makes sense. Solvable.
Then you have NP problems. These are problems where finding the solution might be incredibly hard, but checking if a proposed solution is correct is easy. The classic example is a complex Sudoku. Solving it might take you hours, but if I give you a completed puzzle, you can verify it's correct in a minute.
So the core question of P versus NP is, are all those problems that are easy to check also secretly easy to solve if we just had the right algorithm?
Exactly. If P equals NP, it means there are clever shortcuts for almost every hard problem we can imagine. If P does not equal NP, it means some problems are just fundamentally hard, and no amount of cleverness can get around that brute force reality.
And Hassabis isn't claiming P equals NP, but his hypothesis suggests that when it comes to nature, the problems might not be as hard as we think, that nature's patterns are, for lack of a better word, learnable.
Which is a profound philosophical bet. It suggests nature doesn't use the hardest possible math. This is where the AlphaFold story becomes so important. Protein folding was the poster child for an NP hard problem in biology.
The number of ways a protein could theoretically fold was astronomical. It would take longer than the age of the universe to check them all.
But AlphaFold didn't try to check them all. It learned the patterns. It learned the language of how amino acid sequences translate into three-dimensional shapes. It found a shortcut that wasn't obvious in the pure math of the problem.
And what took scientists years of lab work suddenly took hours. It didn't solve P versus NP, but it showed that for a hugely important biological problem, the pattern was efficiently discoverable.
The implications of that are pretty staggering. If that hypothesis holds true for other natural patterns, then things like drug discovery could be revolutionized. Instead of years of trial and error, AI could design and optimize new medicines almost instantly.
Or personalized medicine. The article mentions treatments tailored in real time to a person's specific genetics. It's moving from a world of brute force discovery to one of, well, pattern literacy. We're learning to read nature's source code. This is exactly the kind of shift we explore here on the Age of Living Intelligence.
Of course, there are major caveats. The author rightly points out that not all patterns might be tractable. Some systems could be truly chaotic or just hard in that deep, fundamental sense. And even if an AI cracks a pattern, we're still left with the interpretation.
The human element. What does the discovery mean? And the ethics. Who owns this knowledge? Who benefits from a technology that can predict the building blocks of life? These aren't technical questions anymore.
No, they're societal ones. And as these tools get more powerful, the patterns they reveal will get more complex and more consequential. Think mapping the rules of emergence in ecosystems, or even societies. The potential for misuse grows alongside the potential for good.
It feels like the real challenge isn't just about solving problems, but doing it with wisdom. Hassabis's vision is this invitation to see nature's complexity not as a wall, but as a dance we can learn the steps to.
Right, to work with complexity, not just against it. Whether or not P equals NP on a cosmic scale, we're proving that large, vital chunks of our reality are, in fact, learnable. And that alone changes everything.
Thank you for listening. And if you enjoyed our work, please like, share, and subscribe.
To dig even deeper into subjects like these, please visit our Medium publication, AGI is Living Intelligence.